4.2. Okay, so 4.2 is more on, it's a continuation on the types of sampling, and we're going to talk some more about randomization and all that good stuff. Just like in the last video, this one's, again, a lot of definitions, unfortunately not a lot of math. So if you missed that stuff, I'm sorry, but don't worry, the next chapter will bring back the math. So let's go ahead and get started. So like I said, a lot of definitions. Most of these should be pretty familiar. Observational study versus experiment. You need to be able to tell the difference between the two. An observational study is exactly what it sounds like. It's just where you set up a situation for a question that you're trying to investigate, and you don't change anything. You just observe. So a good example of this would be if you were trying to measure how the cell phone usage in classrooms, something like that. You wouldn't go in the classroom and say, okay, you guys be on your phone and you guys don't. Like, you just sit back, you observe, and you see how often students are on their cell phones. So you sit back, you observe, you do not change anything. An experiment is where you deliberately change things. So usually you have a control group and you have a treatment group, and then you use that to compare the two groups together to see if there is a change when you offer the treatment. Yeah, so, and you've done enough experiments in science classes, you'd probably be pretty good to think of an example of an experiment. Confounding happens when another variable may be the real reason that something is changing or happening. So the best example of a confounding, or a situation with a confounding variable, would be, I'm sure you've all heard this, the more you study, the better you will do on an exam, right? And there probably is a positive correlation there, but it's not cause and effect, because there's definitely other factors that could be playing into that. For instance, how much sleep you get the night before, your type of studying, who you study with, your breakfast that you ate that morning, your just overall, ability as a test taker. So there's all these other variables that may be affecting the positive correlation there. It may not just be because you study more, you do better on a test. So there could be other variables influencing that correlation. And then the last definition for this page goes back to the experiment stuff. Whenever you're working with an experiment, whatever you are changing or whatever you're applying to the treatment group, that's called a treatment, whatever you're changing. You could have several explanatory variables, and the units that you apply the treatment to, those are your experimental units. And when they are human beings, they're often called subjects. They could be anything that you apply things to. Okay, so I know I have the answer listed there below, but here's an example. So before you look at the answer, you can read through that example. You may want to pause right now and just make sure that you understand why those are the answers that they are. Okay. Okay, so now we have two things, and we kind of talked about random selection last class and the last video, and then today we're going to talk about random assignment. And when you put the two together, you have a really powerful survey or experiment. When one piece is missing, it's just not as good. So before I tell you why that is, random assignment is when you have your units and you randomly assign them to their treatment groups yeah. So here's an example. So you have a class of 30 students who volunteer to be subjects in the caffeine experiment. There was a caffeine experiment earlier, but I didn't give you that example. So just pretend that you know what I'm talking about there. Explain how you randomly assign the 15 students to each of these treatment groups. So the first one is your hat method. With hat method, you're using 30 identical slips of paper. So there's two different ways to do this one. I chose this one where I wrote A, which represents the group with caffeine, on 15 slips of paper, and B on 15 slips without or on 15 slips of paper. And then what I'm going to do is thoroughly mix those pieces of paper up. And then I'm going to draw out a piece of paper. I'm going to draw out 15 pieces of paper. And then, well, no, I'm sorry. I'm going to draw out a piece of paper and apply that to each person. So for person one, I'm going to reach in, I'm going to grab out a piece of paper. If it has an A on it, they go to group A. Person two, reach in, grab a piece of paper. If there's a B on it, they go to group B, and so forth. The other way that you could do this one is you could put all 30 students' names or numbers into a hat. You mix that up, you pull out the first 15 names, and they go to group A, and the remaining ones go to group B. So the second one's a little bit easier to explain, but both are perfectly good examples to use. Using technology, so this would be on the calculator. If you remember this from last class, just as a quick review, if you have the calculator open, it's under second math. I'm sorry, not second math, just math. So just math, and then you go over to probability, and there's your random int under number 5. So you would do random int 130, and then you would select 15 unique numbers. Those first 15 numbers would go to group A, and the remaining should go to group B. Okay, and then last but not least, using table D. Again, this one's everyone's least favorite. You number the students 0, 1 through 30. Again, because 30 is a 2-digit number, my highest number is a 2-digit number. I'm looking for all 2-digit numbers, so that's why the 0, 1 to 30. I'm going to start a row 101. Again, you can start wherever you want, but I'm just giving an example. Move from left to right. Find 15 unique 2-digit numbers, ignoring the numbers 0, 0, and 31 through 99 because they don't represent the students. Then the students who correspond to those 15 numbers should be assigned to group A, and the remaining should be assigned to group B. Okay, now before I move on, I don't know if there's a way to add a page in. It doesn't look like it. I don't want to mess anything up right now. So I just want to talk really quick about random assignment and random selection. Okay, so last class we talked about last video we talked about random selection. And you had 3 different ways really to randomly select, and that's your simple random sample, your strata, and your cluster. Okay, when you randomly select using one of these 3 methods, so simple random sample, stratified, or cluster, you're able to apply your results to the entire population because you randomly selected. So if you randomly select, you can apply your results to the population. Okay? If you do random assignment, so random assignment is going to be one of the 3 methods from below, so using hat method, technology, or table D to assign people or items, whatever it is, to different groups, then you can apply, not apply, you can establish cause and effect. Okay, so if I were to randomly sample a group of students, and then I was to randomly assign them to different groups, then you can establish cause and effect. For instance, if I were to randomly assign people to, let's say, a treatment group and a control group that looks at maybe it's hours of studying versus test scores, if I could establish that there is a correlation there, then I could actually say that that does exist for the population that I randomly selected from. Okay, so those 2 pink things that I wrote up there are super, super important. So if you randomly select, you can apply the results to the population. If you randomly assign, then you can establish cause and effect. So if this, then that, or this is due to that. Okay, so just a couple really important things. Moving right along, the next one is our 4 principles of experimental design. We have comparison, random assignment, control, and replication. And then you can read through those, but basically with comparison, you've got that you need to have some type of comparison there with 2 different treatment groups. So usually that means you have a treatment group and a control group so that you can compare and you can say, you can establish that some type of reaction actually happened. So usually that's going to be treatment versus control. And then I actually talk about control in number 3. That would be your group that gets like the placebo or that just not much changes so that you can make sure that some response actually occurred. Random assignment, we just talked about that. Random assignment is so that you can establish cause and effect. It says they're balancing the effects of other variables, so you're kind of controlling with that. And then replication is that your groups are big enough so that the differences are significant between the 2 groups. Okay, so again, here's an example. I'm not going to read it to you, but take some time, maybe pause the video quick, read through that. I have the answers at the bottom as to what comparison, control, random assignment, and replication are for that question. So maybe try that on your own and then check the answers below. Okay, and then last but not least, 3 more definitions. We've got our completely randomized design. Completely randomized is just where everything is random, randomly assigned. There are some issues with that sometimes, and I'm going to talk about that on the next slide. There's blind experiments and there are double blind experiments. So I forgot to write blind in there. If you have a blind experiment, it means the subject doesn't know if they are receiving a treatment or a placebo, but the researcher does. Okay, so blind experiments are used all the time, especially when they are field testing prescription drugs. So there's actually one of my aunt's friends just had throat cancer, and her it's very, very painful if you know anyone that's ever had throat cancer. Basically, they take radiation and they just like burn the inside of your throat because they're trying to get rid of all the cancer. And it was just so horrible, but they had an experimental drug out. So she entered into this trial, but she received something, but she wasn't sure if it was a placebo or if it was the actual treatment. The researcher, her doctor, probably knew which one she was receiving, but she did not, because what they want to see is if there's any effect with the placebo or if there's more of an effect with the actual prescription. So blind is when the subject doesn't know if they're receiving a treatment, but the researcher does. Now we have double blind. So with double blind, neither the subjects nor the researchers know what the who gets the placebo and who gets the treatment. And there's actually an excellent example of this in Grey's Anatomy. So in Grey's Anatomy, there's an episode where let's see. So, excuse me, Derek, or McDreamy if you prefer, he is conducting an experiment on Alzheimer's patients, and he doesn't know at first what the patients will get until it's actually in there. So I guess it's maybe more of a blind experiment, but I used to love that show. So anyways, if you want a good example of blind and maybe even a little double blind, go watch Grey's Anatomy. And then last but not least, an observed effect needs to be statistically significant. So it means that sometimes there is like a decrease in blood pressure or an increase in test scores, but it needs to have enough of an effect to make sense. I think that there is an example. I think maybe you'll see it in your practice questions, But there's an example of a school that wants to invest in, I don't know if it was like an SAT prep program or something like that. So, they did the research and they did find that kids did better, but they did better by like 1 or 2 points. And we all know on an SAT, like, you know, that's not really significant. So when it says statistically significant, it means that there's enough of a difference that it actually matters. Yeah. Okay. So last but not least, I know I said that before, but blocking is really, really cool. It's very important. I actually love this example and I use this one a lot. And there's a popcorn example that you'll see in your notes. But basically, as I was talking about before, we often in experiments, you have confounding variables. You have other or lurking variables. You have other things that may be affecting the outcome other than just an SAT prep program or in the popcorn example that you'll see in the notes. Okay, so there's other things. There's lurking variables, confounding variables, and blocking is a way to control for those. Okay, so I do kind of want to talk about this example because a lot of people actually get a little bit confused when they're talking about blocking. So if you read through this example really quick, basically what they're saying is, I think it's an SAT prep program. Maybe this is the one I was talking about before. And they want to see if it's better for students to take the program in the classroom or online. Okay, so the improvement here, if you look in the very first graph, so if you look at this one right here, okay, so classroom versus online. So it seems like the online course had a bit better of improvement because they have, a bigger score there. The majority, but they also had, yeah, so the classroom had lower scores, so it looks like the online one was better. But again, there could be lurking variables. In this case, they want to look to see maybe was it that, Algebra 2 students did better or pre-calc. So they want to compare your level of mathematics to others of that same mathematics level. So if you look in this question, I know it's kind of hard to see, but these first couple of blocks here are kids that have taken geometry. And then the circles are kids that have taken Algebra 2, and the triangles have taken pre-calc. So basically they're saying they're comparing the pre-calc students to the pre-calc students to see that change, because you wouldn't want to necessarily compare an algebra student to a pre-calc student or a geometry student to a pre-calc because there's just different levels there. And then you can see in the last one the adjustments there. But what I think is really kind of interesting is, like I said, there's a really good example in your practice about popcorn. So in the example, what they say is, I think they're investigating to see whether the button on the microwave works better or the time listed on the bag. And so what they did was they randomly chose, or they chose 4 different types of popcorn, and then they randomly chose bags and they, popped the popcorn. But what you might want to compare is, how did the butter lovers popcorn do compared to other butter lovers popcorn? You may not want to compare butter lovers to, kettle corn, something like that, because it could be the flavor of the popcorn that's actually influencing whether the microwave button works better than the time. Okay, so blocking is when you have other variables that you want to control for. So we can easily look at this one right here and we can see, is it the math ability that's making the improvement or the math level, or is it the program or the program type that's there? Okay, so that finishes this video. Again, lots of good stuff here. So we started off with experiments versus observational studies, talked about parts of experiments, and then random assignment. Again, super important with the random selection. You can apply the results to the population. That's what we talked about in 4.1. I guess a non-example would be like if you had voluntary or convenience sample, then you can't apply the results of the population, only to the people in that survey. So by random selection, when you randomly select from a population, you can apply the results to the population. If you randomly assign using one of the methods down here, A, B, or C, then you can establish cause and effect. Your principles of experimental design, just make sure you can talk about them Those are all good qualities of an experimental design. Talked about blind and little Grey's Anatomy, as well as your completely randomized design is what we've talked about before now. And then we finished by talking about blocking, which controls for lurking or confounding variables. So hopefully you found some of that interesting.